Good morning, my dear students. Myself, Rupa, lecturer in chemistry. I have completed my MSc, MPhil and B.Ed. I have 13 years of experience in the teaching field. Under my guidance, I have guided 11 students for the project work. I welcome you all for these online classes conducted by Pramana PU College, Raichur. Today we are starting the bridge course. We should know what is this bridge course. Bridge course, it connects the knowledge what you have gained in your school days with that of the pre-university course, first and second year. This bridge course helps you to understand the subject thoroughly and to complete first and second PUC, whatever you require the necessary knowledge, it is covered in the bridge course. You know that chemistry we use in everyday life. There is no any life around us which does not contain the chemistry. For the respiration, we inhale the oxygen and we exhale the carbon dioxide. Water, it is made up of H2O. The food materials what we eat, it contains carbohydrates, proteins, vitamins. These are all the chemistry. Morning what we use the toothpaste for the brushing. Toothpaste also contains the chlorides, fluorides, calcium, carbonates, sorbitol and so many chemical compounds. The soaps, the detergents we use also chemicals, are made up of chemicals. We cannot imagine a life without chemistry. Chemistry is everywhere around us. The baking powder, it is contains sodium bicarbonate, NaHCO3, which is used in the food materials. All contains the chemical compounds. Let us know what is this chemistry, definition of chemistry. Chemistry, it is a branch of science which deals with the structure, properties and composition of matter. It deals with the structure, composition and properties of matter. Let us know the branches of chemistry. There are many branches of chemistry are there. For your first and second PUC level, you have 4 branches you have to study. In that, the first one is the organic chemistry. Second is the inorganic chemistry. The third one is physical chemistry. And the fourth is the biochemistry. Still are there branches, analytical, industrial chemistry, that you will study in your higher education. For your PU level, you have to study these 4 branches. The first one is the organic chemistry. Organic chemistry is a branch which deals with the study of carbon and its compounds. We study the carbon as well as its compounds in the organic chemistry. Example is alcohols, acids. These are the examples for organic chemistry. Next comes the inorganic chemistry. Inorganic chemistry, here we study inorganic compounds. Other than the carbon, compounds are example for inorganic compounds are KMnO4. KMnO4 is potassium permanganate. The third branch is the physical chemistry. The word itself indicates physical. It is the study of physical structure of the chemical compounds. How these chemical compounds react with the matter, how they form bond, and how the atoms are held with each other. We study in the physical chemistry. Last one is the biochemistry. Biochemistry, it is also known as biological chemistry. Biochemistry, it deals with the study of living organisms and their related functions. This is a brief introduction about the subject chemistry and its branches. Let us study some of the things, revise the things what you have studied in your school days. You have studied the matter. What is a matter? Anything which has mass and occupies space is known as matter. There are three states of matter. The three states of matter are solid state, liquid state, and gaseous state. You know that in solid state, the particles are arranged tightly held with each other. They are very rigid in nature. Why these particles are held tightly with each other in the solids? Because between the particles there is a strong attractive force exists. Due to the strong attractive force, the particles are very tightly held with each other. The solids are rigid in nature because of the strong attractive forces. Solid, if I take sugar crystals as well as salt crystals, they are having definite shape as well as definite volume. Solids, they are having definite shape as well as definite volume, and these particles are held tightly with each other. If I take sugar crystals and apply the force, whether it will compress here, the compressibility is very least. If I apply high force, it will break. So solids are not compressible. Next comes the liquid state. In liquid state, the particles are loosely held with each other. The attractive force is less in case of liquid than compared with that of the solid. Example for liquid is milk as well as water are the examples. If I take water and if I place the water in a cup, it takes the shape of that container, it takes the shape of a cup. The same water, if I put in the plate, it takes the shape of the plate. Liquid does not have any definite shape, but it is having definite volume. How you come to know it is having definite volume? Here we can measure the volume of a liquid in terms of liters. We can measure here the volume of liquid in terms of liters. Hence liquid, it is having a definite volume but it does not have definite shape. They are slightly loosely held with each other, particles. Last comes here the gaseous state. In gaseous state, the particles are far apart from each other. They are moving randomly. There is no any attractive force exist between the gas molecules. In the liquid state, if I apply the force, it can be compressed. Little bit it can be compressed in case of liquids. Whereas gases, if I apply the force, it is highly compressible. Why it compresses? Because there is a large space here. The gas molecules can be compressed here. In liquids also there is little bit space, hence the liquid also can be compressed. But in case of solid, there is no any space only. Hence solids are not compressible. Whereas the liquids are little bit compressible, but gaseous can be more compressible. The gaseous particles are far apart from each other. The gaseous particles, they don't have any definite shape as well as the definite volume. Then how to know this gaseous? What is the volume of gaseous means? The cylinders in which we fill the gas, the volume of that cylinder itself is considered as a volume of a gas. But we cannot measure exactly the definite volume of a gas because there is a large space between the particles. Hence, it cannot be, definitely we cannot measure the volume. No definite shape as well as definite volume in case of gaseous state. In your school days, you have studied regarding the metals as well as the non-metals. Metals and non-metals. What are these metals? Metals are good conductors of heat and electricity, whereas non-metals are bad conductors of heat and electricity. Here, let us see the examples here for the metals. Metals example is copper, silver, gold is an example for the metals. Non-metals examples is hydrogen, carbon, nitrogen, oxygen. Metals are good conductors of heat and electricity. Non-metals are bad conductors of heat and electricity. In terms of chemical reactions, if you want to define the metals in terms of chemical reaction, if you want to define means, metals are elements which lose electrons. Metals lose electrons or donate electrons. After losing electrons, what type of ions they form? They form a positive ions. Metals are the elements which loses or donate electrons to form a positive ion. Whenever any metal loses, we write the charge is plus. Plus indicates it has lost the electrons. Minus indicates it has gained the electrons. For example, if I take metal like sodium, Na. Sodium loses one electron and will form a Na+, positive ion. Non-metals, these are the elements which gain electron. These elements gain electron and their charge becomes negative. They form a negative ion. For example, if I take Cl, Cl gains one electron, it will form Cl minus. Oxygen, O, it gains two electrons, it will form O minus 2. Minus 2 indicates it has gained two electrons. Elements which lose electrons or donate electrons, they form a positive ion. Like Na+ is a metal in terms of chemical reactions. We define elements which gain electron and they form a negative ion. Their charge is become 1 electron. O minus 2 indicates it has gained 2 electrons. Their nature is they lose electrons. Non-metals nature is they gain the electrons. After this metals and non-metals, the third comes here the metalloid. Metalloid. What is this metalloid? Metalloid are the substance having the properties of both metals as well as non-metals. They are having both the properties of metals as well as non-metals. Such elements are known as metalloids. In nature, up to now, we have found 8 metalloids and we have placed that 8 metalloids in a periodic table. What are these metalloids? Examples is boron, aluminium, silicon, germanium. These are the metalloids which are having the properties of both metals as well as non-metals. After these metalloids, next comes here the occurrence of metals. Occurrence of metals. Occurrence where they occur in the nature, where it is found. Metals are found on the earth crust. In the metals, the abundantly found metal is aluminium. Aluminium is mostly abundantly found element on the earth crust. After the aluminium, other metals also comes here like iron, sodium, magnesium. They are also found on the earth crust. Abundantly found element on the earth crust is aluminium. These metals, they are generally reactive in nature. These metals, they react with the other elements which is present in the nature. These metals reacts with oxygen, they form oxides. If they react with chlorine, they form chlorides. If they react with nitrogen, they form nitrides. Since these metals are highly reactive in nature, they never be found in its free state or native state. Always it is associated with the other elements. It is found in the combined state. Metals are found in the combined state. We call such metals as minerals. What are these minerals? Minerals are inorganic substances which are naturally occur in nature, which is having a definite chemical formula and structure. They are inorganic compounds naturally occur in nature, having a definite chemical formula and structure. Here, the metals, some of the metals are also found in free state like gold and platinum because they are very less reactive in nature. They are present in the free state. These minerals, if we see the minerals here, they are always associated with the metals. Minerals are the sources for the metals. Then what are the source for minerals? Ores. From ores we get minerals, and from the minerals we extract metals. Then what are these ores? Ores are nothing but they are present in the form of a rocks, and the metals are extracted profitably, then it is known as ore. Ores are the sources for minerals, minerals are the sources for the metals. If I take a ore, it is have 10 tons of ore. From the 10 tons of ore, if I get only 1 gram of iron, is it profitable here? No. Then we don't consider it as a ore. From the ore, if we get the minerals and if it is profitably used, then only it is considered as a ore. All ores are minerals, but all minerals are not the ores. The extraction of metals from their respective ores is known as metallurgy. Extraction of metals from their respective ores. The process is known as metallurgy. What is metallurgy? The extraction of metals from their respective ores is known as metallurgy. If I take the ore, for example, bauxite. Bauxite is a ore. It is an ore for aluminium. We extract metal aluminium from its respective ore, that is bauxite. Extraction of aluminium from bauxite, and the process we call it as a metallurgy. We can extract iron metal. The ore for iron metal is iron pyrites, as well as the ore for this iron is hematite. Hematite as well as the iron pyrites, these are the ores for the iron. We extract iron from either iron pyrites or the hematite. What is the metallurgy? Extraction of metals from their respective ores is known as metallurgy. This is about the occurrence of metals. After metals, next comes here occurrence of non-metals. Here, the non-metals, where they occur in nature. Let us see here. First non-metal is hydrogen, nitrogen, oxygen, sulfur, carbon, silicon. Among these non-metals, all these non-metals, they exist in free state, native form, except silicon. Silicon never exists in its native state. Always it is present in the combined state. Hydrogen, it exists in the native state as well as in the combined state. When hydrogen reacts with oxygen, it will form water. Similarly, nitrogen, when it comes in contact with oxygen, it will form as nitrates. Oxygen, it exists as a free state as well as combined state. With carbon, it will form carbon monoxide. With sulfur, it will form sulfur dioxide. Here, the sulfur also exists in the free state as well as in its combined state. It exists as sulfates, sulfur dioxide, and so on. Sulfates, sulfides, sulfur dioxide. Carbon, it also exists in native form. In native form, it is in the form of diamond, as well as it exists in the form of a graphite, as well as it exists in the form of a fullerenes. These are in the native form. Native form of carbon is diamond, graphite, and fullerenes. This carbon exists in the combined state. It exists in combined state as carbon dioxide, carbon monoxide, carbonates, bicarbonates, and so on. Hydrogen, nitrogen, oxygen, sulfur, carbon, all they exist in the free state combined state as silicates. If we see this non-metals, the first abundant non-metal in nature is oxygen. Oxygen is the first abundant non-metal. After oxygen, second non-abundant non-metal is silicon. Second is the silicon, third non-metal is the hydrogen. This is about the occurrence of metals and non-metals. In the next session, we discuss regarding the physical as well as the chemical properties of metals as well as the non-metals.